So this particular actuator here is being pulled by pulleys and belts. I can actually show you the inside of one in a second. Sometimes I show this to people and they say, what is this, a ray gun? One of the cool things, as I mentioned, is we can build a digital twin. So you're seeing a digital twin of the system.
Nice.
Right? That's at 0%, and then that's at, say, 90%.
So it looks like you're holding a game controller.
That is true. And this is on a 4-bar linkage, so the end effector stays level as we're moving through the lift axis. It also azimuths, so left and right on that axis. We're also able to tilt left and right.
Hey Jeannie,
Yeah, Brew.
where's the nerd show today?
Today we're in Somerville at RISE Robotics with RISE Robotics CEO Hiten Sonpal. Hey Hiten.
Hey, Hiten.
Hi, I'm so glad you guys could make it out.
Thank you. It's really good to be here. I've been curious for a while about what is RISE Robotics and what are you doing here?
Yeah, so we are working on hydraulics replacement technology, right? And so what we've done is we've taken the oil out of hydraulic cylinders and replaced it with belts and pulleys, and we call this technology beltdraulics.
Beltdraulics. Okay, has a ring to it.
Of course, it's fluid-free, and as you know, hydraulic oil is hazardous, so you don't want to spill it. It's also messy, but it is the state of the art when it comes to heavy machinery. So some of these factories that have a lot of hydraulic oil, once the factory shuts down or they move, that site has to get cleaned up. It has to be remediated. It's very expensive. But what's even more interesting is that because it leaks so much, it's hard to maintain, right? It is still the state of the art for heavy machinery, though, and that's what we're changing. With our beltdraulics technology, we've developed something that's 3 times as fast as hydraulics, so more productivity, more revenues for folks that are using our technology. It's 3 times as efficient, so energy savings, operational efficiency improvements. It's also 80% of the weight. It has built-in position sensing, built-in force sensing, built-in health sensing, which makes it AI and autonomy ready.
Built-in health of
The components
pulleys and the belts.
Yeah, specifically the belt. The belt is the thing that wears, and that's the thing that people ask about the most. If you think about a hydraulic oil system, the hydraulic oil leaks, and you have to refill it every now and then. With our belts age, and then before they break, we know that they've been stressed because there's polyurethane on the outside and steel on the inside, and it's not even that smart AI. We just put electricity through it, and you know, as soon as the conductivity changes, we know that we're getting to the point where the belt has to get replaced.
That's amazing. So how is it being used so far? Like, what have you tried?
Yeah, so I'll take a step back and talk about the company a little bit.
Okay, great.
Right? So the reason why we're called RISE Robotics is that the founders of the company decided that they wanted to build an exosuit. So think about like a big mech, you know. So this is to help soldiers out, help the elderly, help folks that are working in production facilities and warehouses so they could lift heavy things.
People who want to fight bears.
And people who want to fight bears, right? And gators, right? We work for gators too. So they're working on these, designing these exosuits. And as part of that process, they started to look at how they would transfer power. And so, of course, hydraulics being the state of the art, they looked at hydraulics and they realized it's quite complicated and messy, really. You had all these hoses and cables, and you had to get pumps in there, and the hydraulic systems were heavy. So they started to say, okay, let's take a step back. Let's take a look at nature for inspiration. And when you think about nature, about the only thing that the human body does where it's using fluids and compressions is the heart. But most of the other movement is being done by fibers and tension, right? So even if I'm pushing you, there's actually a muscle here that's pulling to get the force to push you, right? And so they started to look at what are some fibers that we can use to create this tension. And they found these belts that had just come out maybe a decade earlier. And they are polyurethane belts with steel on the inside, as I mentioned. And they started showing up in the elevator market. So they're replacing the steel cable that you would see in an elevator with these belts. And the belts would last the life of the building because the polyurethane on the outside protects the steel on the inside, and then there's no steel on steel friction, so you don't have abrasion, and it just lasts forever. So they started with those belts, and then started to think, okay, how can we package this into cylinders? And then that's how we came up with the beltdraulics technology. And then they realized they'd have to create the exosuit market. It's much easier to target an existing market, the hydraulics market, right? And
Like heavy machinery.
like heavy machinery.
Construction.
That's right. And the timing is right because everyone is trying to electrify these machines, right? They're trying to clean it up. And so that's where this technology makes a ton of sense.
Cool. Can we look at them?
Yes, sure. So this is our production area where we build our cylinders. Behind is our electronic space. We got some space for inventory. You can see the tools. Let's actually take a look at one of these systems from this side. So let's get a camera here.
Here.
So this particular actuator here is being pulled by pulleys and belts. I can actually show you the inside of one in a second of what it looks like in here. But the belt gets spooled into this spool, and there's actually a traction drive that's pulling all this stuff. These are the electronics that power it. There is a motor and gearbox underneath here, which is actually difficult to see. In this particular case, we've mounted a fan to see how far we can push this. So we have a standard rating, but we're actually running some experiments on this one to see how fast can it go.
What if we want to push?
Right. So this particular cylinder doesn't have the ability to push. It only has the ability to pull. But we have a version that's in our test fixture, a prototype that can both push and pull. And then we're launching a samples program where we'll be selling our first cylinder that can push and pull in April.
So where's the best place for us to see a demonstration?
Okay, let me show you a demonstration of our developer kit.
Great, thanks. So while it's booting, can you tell us what's going to happen?
Yeah.
Yeah.
So there's a control UI here, and you'll be able to use this touchscreen to control this sample that we'll be selling. Of course, our sample won't have this. It'll be a little slimmer, and it won't have the spring because it'll be double acting, right? So this is double acting. It can push and pull, but the pushing is happening with the spring, right?
Oh, okay.
Right. And so that means that it's halfway.
Ooh,
Is that the belt?
that is the belt.
belt.
Wow.
Is that the belt all wound up on that?
Yes. That's where the excess belt goes.
Okay, so what is this telling us?
So this particular thing, so one of the cool things, as I mentioned, is we can build a digital twin. So you're seeing a digital twin of the system,
Nice.
right? And what we can do with this system is we use this to demonstrate multi-position and the various speed modes. So let's start by enabling this, and I'll put it in position mode. And let me actually just take it to its two extremes to make sure that it can go the full range. So that's at 0%, and then that's at say 90%. Okay. What I'll do here is, excuse me, I'll put a cylinder here so we can just see how precise this is. It's at 80%. I'll put the bottle here. And I'll take it to 10%. I'll take it back to 80%.
Oh yeah, look at that.
Man, can your hydraulic actuator do that?
No, they're usually not multi-position because you can't control the fluids that precisely. So that's the position modes, and then we show the speed modes, and so that's at 10% speed. And then I can take it to 50%.
Ooh.
100.
Oh. I'm going to stop this.
Yeah.
Yeah. So anyway, that's the
Okay, knock
so
it
that's
out.
the developer kit.
Yeah. Oh, that's neat. So is the developer kit what people are going to take as samples?
Yeah, so this is the sample, and then they get this touchscreen UI so they can run it through tests. So in this particular case, they'll probably end up suspending the actuator in some way, putting a load on it, lifting it, and then they would run it through a large number of cycles. And of course, we have belt health, and we'll tell them it's getting close to breaking point.
Could you make a pogo stick for like a 1,000-pound person?
Yes, there was actually there's actually a prototype pogo stick floating out here somewhere.
Oh my gosh. Sounds dangerous. People wear a helmet.
This was before my time, so
Okay,
I
all
doubt
right.
it.
Okay. That's fun though. And now you're going to market with
That's right.
some new customers. And I don't know who you have in mind.
Well, we have a huge list. So there are plenty of companies that have contacted us in the past and said, "Hey, we want to collaborate," and it's always ended at, "Okay, we could do this for you, but you need to spend this much in development before we can get you a cylinder." Now it's very different. It's going to be, "Hey, remember we spoke last year? we now have a cylinder we can send to you. It's not exactly what you want, most likely, but why don't you try it, and now you'll be convinced, and then we're now much closer to having an agreement.
Very cool.
So this kicks off our components business, right? So every one we send these to will likely have some system that they want to put one of our systems into. But we are also becoming an OEM of our own product so that we can deploy something in market, work directly with customers, figure out what those issues are, and then if there are anything, we can improve our technology because we will also be the consumer of the product. And that's our liftgate product, which I'll show you in a minute.
All right, come on out. This is our all-electric liftgate. Traditionally, liftgates have hydraulic cylinders that are in these runners that help it move up and down. We have replaced that with a block and tackle, pulley on a motor sort of situation, so then it's all electric. It's really smooth. As you can tell, this is one of the quietest liftgates that you're ever going to see on the market.
No pumps, no fluids, no mess.
No pumps, no fluids, no mess. Can I show them the battery box?
Sure.
Is that cool? Okay, come with me this way. So usually, in a hydraulic liftgate, like you were talking about, there's pumps and fluids and all of that. And there are two separate boxes that are about this size next to each other. One that holds all the batteries and one that holds the pumps that I just discussed. So usually there's 4 different lead batteries and we only have the one here. What's really great about this battery is that we are able to recharge it. That's why it's called Regen Railtrax, because the motors, as they run, because we're lowering so much weight, will go directly back into the battery, which is really great.
So we're able to develop a category of machines that I call perpetual unloading machines.
Right?
They're not perpetual machines, right, which we know don't exist, but they're perpetual unloaders because the energy they need to operate, they extract from the potential energy of the thing that they're lowering, simply because the efficiency of our technology is so incredibly high.
Wow.
Just like an electric car decelerating and charging its batteries, that's what we're doing all the time. Is we have this force and we're turning that into electrical energy. So you can imagine an application where we're unloading a container ship, right, with a container handler that uses our technology, and we could be unloading perpetually.
Yes.
Right? Just unload because the energy to unload was loaded where the containers were loaded, right?
Right. Gets
But
much
even
energy.
if we had to lift it, we're still 3 times as efficient as hydraulics, right?
Yep.
Awesome.
And can go much faster than hydraulic under those higher loads.
Oh, wow.
Would you like to ride the
I do. Oh man, I want to ride the lift.
you want to ride the lift gate?
Yeah, let's
okay,
do
let's
it.
do it.
So now we're generating.
So what's exciting about this is because you don't have a pump, you don't have hoses, the installation time of our lift gate is 5 hours. The standard installation time for a railgate like this is 30 man-hours, 30 person-hours.
Wow. And are you selling this to electric trucks?
Definitely electric trucks could use it, but we're selling them to any trucks because
Because it's better.
yes, usually it goes on a trailer, right? 90% of the market for lift gates is trailers, 10% is box trucks. And all the trailer manufacturers are really excited because they want to get the hydraulics out of their shop. They don't want the oil, right? And they love the fact that they can install in 5 hours as opposed to 30. We'll be in production the second half of the year. We're doing a pilot this month.
So as this closes, you can see that it's very controlled. On traditional hydraulic lift gates, it's more of a slam, right? And so a lot of operators will hide behind the truck to protect their ears, which is obviously a huge safety issue. So with this being so controllable, not only is it better for workers, but it's also safer because it's moving slower.
That's so cool.
Yeah.
So this is Nolan, one of our mechanical engineers, who's going to give you a demonstration of our munitions handling unit. We call this the Super Jammer.
Yeah, so this is the Super Jammer arm. It's a 6 degree of freedom robotic munitions loading arm for the U.S. Air Force. We've been working on this for a couple years now and have had a number of successful demos at various Air Force bases in front of Air Force stakeholders and users. And we've been able to basically integrate some design changes based on those sets of feedback. So, like I said, it does 6 degrees of freedom. It can go up and down, like that. And this is on a 4-bar linkage, so the end effector stays level as we're moving through the lift axis. It also azimuths, so left and right on that axis, We're also able to tilt and roll. So kind of rolling that whole end effector forward. There's a significant improvement from the existing machine, which only rolls 7 degrees. And we're able to roll 55 degrees and completely eliminate one of the tricky adapters that they have to use. We're also able to tilt left and right. And the lead screws that actually enable the 4-bar linkage are what are controlling this. So when they move together in unison, it rolls, and if they move equal and opposite, it tilts. A couple other things we're able to do are longitudinal forward and back. So this helps when they're near the end of their load. They're able to kind of fine-tune that position. And then we're able to yaw also, which goes all the way around like that. So using these 6 degrees of freedom, they load munitions up to 7,000 pounds in their load barns or out in the field. And so this thing long-term hopefully will be sent to various Air Force bases around the world. So one of the number one issues that airmen have with the current machine is hydraulic leaks. There's actually specs on how much it can leak for it to be okay. And a big initiative with this modernization of the Superjammer arm, or of their existing 6 degree of freedom arm rather, is the elimination of hydraulic leaks and drift. And using our RISE beltdraulic technology and some off-the-shelf electromechanical actuators, we're able to completely eliminate the need for hydraulics, drift, leaks, and make their day go by a lot more efficient.
But tell me what you saw at the base.
Hydraulic oil everywhere. We actually needed to use one of the existing machines to load up one of the munitions onto our arm. And as soon as they drove away, Kyle was almost slipping on hydraulic oil that they had dripped, just around our system.
Apparently there's a machine at all of these bases that's like a Zamboni that goes out there and is used to suck up all the oil.
Yeah.
So you can imagine that there's one other person that's just doing cleanup.
So Nolan, I'm curious, can you tell us about any of the changes you made in response to the stakeholder feedback?
Yeah, sure. So we got a lot of feedback around the speeds. We were able to tune those. There was also a need where we went and saw some loading operations that we hadn't before, and we were able to build in a design iteration where we're able to yaw with the forks 90 degrees, which was not in kind of our requirements list before. So it was addressing some of the user feedback, also finding hidden requirements that we were able to iterate the design on. We also were able to integrate a manual lift and lowering operation in the case of power failure. So that's a big thing. They actually run through tests where, the number one, which is kind of the person leading the effort, will say, all right, pretend your power just went out. What do you do? And they'll have to go out and, utilize the current system in its power loss capabilities. And that was something that we were able to integrate in this most recent design iteration also.
Is it a plus that the operator can be like in the other room or
Yeah,
far away?
Yeah, so
controlling it?
probably the most difficult loading operation is when they have to mount an adapter onto the end effector and then manually crank that adapter 55 degrees, and it actually rolls kind of up and over them. And the controls for the arm at that point are on the arm. So in order to move it, you have to be underneath the load. And what we're integrating here is a tethered controller. It has to be tethered for security purposes, where instead of doing that, you're able to actually step away outside of the load path of the potentially falling munition if it ever does.
Stay away.
And there's both like a psychological safety there and obviously physical safety.
And speaking of controllers, it looks like you're holding a game controller.
That is true. So this is a controller that is rated for EOD use and battle tested for certain EMI, EMC resistant mil specs. So this is not our controller that we will be planning on going to production with. We're in the process of figuring that out. A few key piece of user feedback that we got at our most recent demo, I did a deep dive on what their ideal controller is for fine remote control at the front of the end effector. And some key takeaways there were they want to operate it with one hand. They want to have it be mountable to the end effector, or rather the arm. they're used to, without looking, triggering the levers and operating the arm because this is their bread and butter. And if they're over here having to look at it or use two hands, that was really not going to fly. And then they really like the paddles, which spring back to center. So, you're not at risk of uncommanded motion.
Are there other applications or other user groups that you either have met with or expect to meet with on this?
On this particular product, yes. So we're working with the Air Force on this initially, but the Army uses them, the Navy uses them. So we're in early conversations with those. This particular project is funded by the Air Force because they have a more urgent need. And so they're sort of leading the effort. I'll say one thing that's exciting about this for me is, before I joined, is just getting a sense of the strength of the engineering team. So it's not just the fact that we have a cylinder, but we're able to build up this very complex and very capable piece of equipment. This actually is the world's strongest robotic arm.
Yep.
And it exists here in Somerville, Massachusetts, and no one knew about it. We talked about the cylinders. We talked about this is a subsystem that would go on a vehicle, and then you saw a full product on the outside.
On the truck.
On the truck, yeah. That was the lift gate, and that's a full product. And then I wanted to show you something exciting behind you. So this is the very early development of our forklift, right? So that particular cylinder can lift 22 tons. And we did some tests yesterday. We're not testing today, but we'll be testing again Monday. But you can see how impressive it is. The final specification for this cylinder is a 10-foot stroke. So it'll extend 10 feet.
How much did you say it's going to be able to lift?
Nolan, how much weight is loaded on here?
There's 19,000 pounds on here, and based on how the linkage works and the chains from the actual body of the forklift to the forks, it's about a 2-to-1 ratio. So the cylinder itself sees twice the load on the forks. That includes the weight of the forks and the friction in the system. So we're able to get the cylinder up to 50,000 pounds or 22 tons, which is what it's rated for, with about 19 to 20,000 pounds on the forks.
Wow.
Eventually this goes on a machine,
Yep.
right? But we're testing sort of the main actuator. So the two big actuators on most machines that you have the most trouble electrifying are the lift actuator, and for a machine this heavy, you have the steering actuator. Those are the two big ones. And then we can double up these our actuators, right? Because they're so precise. We could put two of them and control them very precisely, very easily. So while this is lifting 19,000 pounds, we could lift twice that. Plus, we don't have to double up the fork, so it would be even higher, right? Yeah.
What's this one doing?
That's a test fixture, and so that's where we would update the cylinder. So you can see at the top, an engineer can get access to it, right? And at the bottom, we can change the load. And so it's just mounted in that way for folks to be able to maintain it and fix it and upgrade it. The same thing is true for the lift gate there, right? So again, the engineering team can get to it at the top, and then at the bottom, we can work on it and add stuff.
When it lowers, it regenerates?
It does regenerate,
Oh my
right? That was the
gosh.
other one, right? So that's the second one. It's the most efficient, and then also the most productive, because we can run up to 3 times as fast as a hydraulic system. So with the same forklift, you could be doing up to 3 times as much work,
Wow.
which is exciting.
So I'm thinking about ports. I'm thinking about ports and like Port of Oakland, giant port, moving all kinds of stuff around. And there's all kinds of problems with local air pollution, fossil fuels we need to decarbonize and clean up the ports. And it seems like technology like this would be
Welcome.
Ideal?
Wanted.
ideal.
Yeah.
Yes.
Exactly.
Yeah,
Exactly.
the state of California is committed to getting all the ports to zero emissions by 2030.
How are they going to do that?
Not without our technology, that's for sure, because the challenge ends up being, well, first of all, it's the cost of electrification, right? So without our efficient cylinders, the batteries end up being twice as large as they need to be, right? So electric equipment,
So it's
these
expensive.
large forklifts become expensive. Then the state of California has to give people rebates, and so those rebates are all gone within the first 2 weeks of the year, because people wouldn't buy the electric equipment without the rebates. And the rest of the time, no one's manufacturing or selling anything. And so we had a conversation with them several years ago, where we said, what you need to do in your regulation is to start to specify the efficiency of the actuators, not just say you need to be electric. Because if you drive efficiency there, then everything else will be possible. Electrification will be possible, and not only that, the grid will be able to support the increased energy demand. And at that time, they didn't buy our conversation, but they gave us a follow-up a few months ago saying, hey, the energy efficiency at the edge concept that you were talking about, yeah, we'd love to talk to you more about that. So we're in conversations with CARB about that.
Good.
So this is a very early prototype of our double acting cylinder. And the piston's over there. And you can see from the way the belts are structured that we're actually pulling and pushing on this cylinder. And then over here is a very complicated test setup to characterize the performance of the equipment.
How hard is it pulling and pushing?
That's right. Yes. Yeah.
So I'm thinking historically about the innovation and how pneumatic cylinders replaced pulleys back in the day, right? We for all the construction, excavating equipment, and it's just a classic story. And now it seems like you're working on going into the future with better technology, but in some ways it's undoing that innovation.
That's right. You're absolutely correct. It's all about the ceiling, right, for each technology. So so my understanding is that there were electric cars, very early when cars first came out.
Yeah, the first cars.
Yep. So folks were trying to make them electric, and then it just so happened that at that time it was easier to improve internal combustion engines than it was to improve batteries because the material science wasn't that mature. And then we got to a point where you hit the ceiling on internal combustion engines. And then there was this demand for smaller and smaller pieces of technology, so laptops and so on, and then cell phones, and all of those investment dollars have really pushed the material science down to the point where batteries are so much better than internal combustion engines today, right? And so the same thing is happening with belts and pulleys. You had the steel cables or the steel ropes a long time ago, and the pulleys, and then at some point, the hydraulics started to have more capacity, and they were environmentally sealed and so on and so forth. So you started to see a huge adoption of hydraulics. And now we believe that hydraulics has hit its ceiling, and we've got new types of belts. And this is just the beginning of the curve for belts because steel and polyurethane aren't that exotic of a material. And so coming down the pike are things like carbon fiber, which are really going to increase the strength of these belts. And so the power density of our cylinders is going to increase substantially. And so all of those changes are still to come. But hydraulics, for the most part, has plateaued.
So are you doing that research and testing about the new materials, or you rely on collaborators to do that?
We rely on collaborators. So one of our investors is Gates Corporation, who actually makes the belts that we use. So we're fully aligned. They want to see us succeed, because if we succeed, then we'll buy more belts. And it's been great working with them. We work with their teams on improvements to the belts, the specific items we want and how we want them to perform. But we wouldn't be doing belt research because it ultimately doesn't matter where the belts come from. Our patents are all around taking those belts and putting them into a very compact factor and doing all of that very efficiently.
Very cool. Well, this has been a really great visit. I'm just so excited to see this stuff in real life.
Thanks for the tour.
Thank you for coming. I'll say that there are two things that really excite me about RISE. The first one is that all the work we're doing from an energy efficiency perspective brings down cost of goods, right? Because the sectors we're going into, transportation, logistics, and so on, they all impact the price of day-to-day items, right? And so the work I'm doing, it really helps improve the quality of life and the wealth of everybody, right? It's the opposite of inflation. And of course, the other part is that everything we do with energy efficiency ultimately ends up keeping the planet cool. So I think those are sort of two major things. And I think what's going to be easy about the adoption of this is that we move faster. So anyone we sell it to, of course, they'll save money in operations because they're consuming less energy, but they'll also make more money because they'll have more throughput with whatever equipment they're using. So very exciting place to be. When I joined, Aaron, one of the co-founders, mentioned to us that we had a huge community of folks that were excited about our tech. And Aaron told me the story of a couple of suppliers who came in here to drop off some equipment, and they would see what we were doing, and they'd say, "What's going on?" And then we'd explain it to them, and then they'd say, "Oh, how can I get in on this? How do I invest? Is there a way I can own a part of your company?" And so what we decided to do recently is we took our last investment round, and at the same terms, we opened it up to the public and our community, because we want to turn folks that are associated with us into champions, help us with business development, network contacts, and so on and so forth. And we launched on WeFunder 3 weeks ago, and we shot up to #1 on WeFunder as the #1 most raised company on that platform, and we were #3 across all crowdfunded companies in the United States, which is really exciting.
Oh, congratulations.
Congrats.
Yep. And it's been 3 weeks, and we've had $500,000 raised from small investors.
Wow,
Which is
that's a big
huge.
success. Oh my
Yeah.
gosh.
And the round is still open, so if any of your viewers find that this technology is cool and want to invest, we'd love to have them.
All right, and where would they find you?
WeFunder.com/RISE Robotics.
Beautiful.
Thanks,
That's
Hiten.
awesome.
Thank you.
Yeah, thanks so much.